Hello everyone, welcome to today's simulation class in which you will carry out a torsional analysis of this compound shaft. The main outcomes of this lecture are to evaluate angle of twist under these loadings of this shaft as well as to compute shear stresses in this compound shaft that is made of brass and the aluminium. So let's start our study now. So first of all, make a sketch on the right planes. Draw three concentric circles. 1, 2, 3. And assign dimensions or diameter to this circle. The size of outer circle is 60 millimeter and the mid one is 40 millimeter and the inner one is 36 millimeter. After that, exit from sketch now and make extrude. From selected contours, clear selections. Then select these three contours 1, 2 and 3. While the depth of extrusion is 625 millimeter. Okay. Now show off your sketch. Again, select this sketch and go to extrude. Clear the sketch. And from extrude conditions, select surface, face and plane. Then select this face. And for the sketch contours, select inner one as well as this mid one contours. And the depth of extrusion is 400 millimeter. One thing more, go to edit sketch, then unmerge the result. That will result two separate bodies. You can see here is the body 1 and here is the body 2. Again go to the extrude cut, select this sketch and go to the extrude cut. Then clear selections from contours and select the inner contours. Then the depth of extrusion is 250 millimeter. So we have created a compound shaft in Solidworks. It's time to load our simulations modules in Solidworks. First of all, save your work before going or moving forward. So from the simulation tab, start a new study. Give it a specific name to your study, that is torsional analysis of shaft, and ensure that static simulation is selected. After that, first of all, treat both bodies as a beam. So right click on each body and select treat as a beam. You can see beam symbol has been appeared and the joint has been appeared. Again, treat second body as a beam. Then assign material to first body, that is a brass. So from the copper alloys, select the brass, apply, close. Similarly, assign the aluminum alloy 6061 to second body. So go to the aluminum alloys and select the 6061 aluminum alloy, apply, close. And from the interactions, go to edit definitions and ensure that bonded contact is selected. And from the advanced options, ensure that surface to surface contact option is selected and check the enforce common nodes. Now apply the bounding conditions, that is the fixed boundary at the left joints. Select this joint and OK. We have made this body hidden. Now apply a torque on this joint. So go to the external loads and select the torque. Then selection box, select the joint, then this joint, and from the direction, select the front planes. And from movement, select the along direction 1, enter the value of 1600 Newton meter. So we have applied a torque here. Just copy these values and paste here and paste here. Then go to edit definitions. Then clear selections and select this joint. Then change the value to this point, that is 800 Newton meter. Now show up both bodies and start your simulation study. The blended curvature based picture does not support, no problem. Okay, go to edit definitions. Change the value to megapascals. And from here, select the torsional stress. And change the scale to true scale. Then floating. So you can see that the maximum shear stress is 63 megapascal and minimum is 56 megapascal. You can show the maximum and minimum shear stresses. So minimum shear stress occur at this joint and the maximum shear stress occur at this joint. Now it's time to evaluate the angle of twist. Just go to edit definitions to displacement. Select two scales. Then position about x-axis in x directions. And change units to degrees. You can see the maximum rotation in x direction is 4.63 degree. That is the angle of twist under these loading conditions. So in this way, we evaluated the shear stresses or torsional stresses due to torque applied on this compound shaft, as well as the maximum angle of twist that occurs here on this compound shaft. I hope you enjoyed this lecture. Please make a practice of this simulation in SolidWorks.